folks. A few months back I introduced the first fractional powered gas solenoid system. Basically a means to turn the gas on and off using battery power, specifically designed for non-powered gas appliances. Today I would like to introduce a control board that works with the fractional powered gas solenoid to form a battery operated burner control system. The battery operated burner control system will provide all the necessary control and safety features and functions necessary for a non-powered gas appliance. Let's take a look. Okay, so you may recognize the setup from the video for the fractional powered gas solenoid system. Basically we have an oven burner, fractional power solenoid, and it's still fed with a propane bottle and a regulator off a gas grill. And we're still using a 9-volt manual module. And the solenoid feeds the gas to the oven burner. Now there's been a couple additions. First of all, we added an electrode here. Or actually we added one here, and this is a spark electrode. And then we're using another electrode for flame sense. We also added the EG thermostat, and the sensing bulb is mounted a couple inches above the oven burner. And I put a little LED here to tell us when there's a call for heat. And we're operating off the same 6-volt battery pack that has 4 AA alkaline batteries in it. Now the burner control board provides the control functions and safety features necessary to safely operate the oven burner. Fractional power control board, solenoid control board, and solenoid control the gas. Basically the EG thermostat is turning the power on and off to the system. The burner control board has an output that controls the manual module and turns it on and off for sparking. It has an input for flame sense, and the way it's set up right now, because we're prototyping, it's providing the power to the solenoid control board, and we also have some communications between the two boards. So unlike the mechanical system, where you have to set it to a light position and light a pilot and then select your temperature, in this case simply walk up to it and turn it to the desired temperature. In this case I've set it to about 250 degrees. Okay, in the normal operation, it applies power to the system. The burner control board will wait for a signal from the solenoid control board and tell it when the solenoid is closed. When it gets that signal, it will turn on the spark module and it'll start looking for flame sense. Once it detects flame, it shuts off the spark module and the burner continues to operate. until the thermostat sees the temperature has been reached and shuts off the power. Okay, now some of the safety features, let's say you had an interruption in gas. Let's turn off the gas supply. So because we lost flame sense, the control board then sparks the module for 4 seconds, and if it doesn't see flame sense, it shuts off the solenoid and the spark. Now since there's no auto retry in the system, to try again, you turn the thermostat off and turn it back to the desired temperature. Okay? The other possibility is, let's say, for some reason we lost flame sense. I disconnect the flame sense probe. Since we didn't detect flame, it sparks for 4 seconds and then shuts off the system because we did not see a flame sense signal. And once again, for retry, turn it off, turn it back on to the desired temperature, set to 300. Okay? And once again, the components used on the burner control board are industry standard parts and readily available in both through-hole and surface mount. And these two boards in production could be just one board, which would save cost, and you wouldn't have the interconnects. And again, I've set this up to turn on and off a manual module, which is one approach. And I did it that way because some non-powered gas appliances already have a manual module in them. So let's see, I'll hook up the power supply. Instead of the battery pack. Okay, and let's turn this off. We'll set our power supply for 6 volts. Lower. Alright. The battery operated burner control board was designed to work in the same voltage range as the fractional power gas solenoid. Alright, let's go down to 5 volts. Okay, and let's go down to 3, or I'm sorry, 4. Alright, let's go down to 3. Thereabouts. Okay, and disconnect the flame sense probe. And all the same features still function at 3 volts. Four seconds to spark, and it shuts off the gas. Oops, sorry, shut the thermostat. Try that again. Okay? Shut off the spark and the gas. So we're in a safe situation right now. No gas flowing. And once again, a retry. Okay, the big advantage to this system, I believe it's going to be cost competitive with the mechanical system. And the two real big advantages is there's no push and hold in lighting a pilot. And also, you can go all the way down to 150 degrees. Whereas most mechanical thermostat systems are limited to around 200 to 250 degrees. Okay? If you have any questions, suggestions, comments, please feel free to send me an email. If you're interested in the system, just send me an email and I'll be glad to discuss it with you. Thanks again for watching.